Hello, and welcome to the next video in the Limiting Reactant series. In this video, we look at method B. This is an arbitrary name just for a different method of doing a limiting reactant problem. Given grams, you need to find grams. Alright, we are using our same propane combustion reaction, so hopefully by this point you're getting really good at writing the combustion reaction and balancing it. So we've got our propane plus O2 gives CO2 and water. Balance this. Alright, so the next thing that we can do is to write our given. So given 92.6 grams of propane and 360 grams of oxygen. Again, I'm given two amounts for reactants, so I know it's a limiting reactant problem. I have to decide which of these runs out first, and I can't do it just by looking at the grams. It's not necessarily the smaller amount. If it works out that way, it's by coincidence. Alright, so let's look at this. Now in this method, we are going to immediately get to moles. So to go from grams to moles, we divide by molecular weight. And I worked out the molecular weights ahead of time by looking at the numbers on the periodic table. So those are in grams per mole. So I'm going to rewrite the equation with the given moles now. Alright, now these moles that I've written are in 4 and 5 digits, but really I left the full numbers in my calculator, okay, and did not round off to sig figs just yet. Alright, now these are my moles. Now what I do is I look at it and see if I can figure out which is the limiting reactant. It's a little hard with these numbers to know for sure. I think it's the propane, but let's see how we can make sure. In method B, throughout we've been using ratios, so we'll look at a ratio here. So I start out with a ratio, mole-mole ratio from the balanced chemical equation, using the two items I'm interested in, O2 and the propane. So I know that for every 5 moles of O2, I need 1 mole of propane, or 1 mole of propane requires 5 moles of O2. Well then, how many moles of O2 would be required for 2.0993 moles of propane? Now, I just arbitrarily chose to use the propane here. I could have used the 11.25 moles of O2 and had a question mark or X for the C3H8 moles. Alright, so when I find out what that question mark is, I punch it in the calculator and it is 10.4964 da 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 da. Calculator gives me a whole lot of digits. Alright, so that's how many moles are needed to react with all of the propane. Alright, well, I have 11.25 moles of O2, so I have more than is needed, which tells me that the O2 is not limiting. So, the propane limits. Now we use the limiting reactant to calculate the amount of product formed. We have several options for doing this. We can either do a ratio or we can do kind of a multiplication with the mole-mole ratio. Alright, so in using this, I can set up a ratio from the balanced chemical equation and then say, alright, so for every 1 mole of propane, I get 3 moles of CO2. So how many moles of CO2 do I get from the available propane? And cross-multiplying, I get a little over 6 moles is what I get. Alright, another way of doing this is to use my available propane moles and multiply by the mole-mole ratio. Either of those two methods work. Now that is moles of CO2 and I need it in grams, so multiply by the molecular weight. And from that I get 277 grams of CO2 formed with the